So we welcome now Mr. Saint-André, who is going to have a talk about Jabber from the point of view of the secure communication. Yeah, please.
Okay. Hey, Dries. We're ready now, Dries. So I'm here to talk about secure communications. My name is Peter Saint-André, but I don't speak any French. StPeter@Jabber.org is my email, Jabber address, and everything I always say is in the public domain, so none of this copyright garbage. I'm here to talk about secure communications with Jabber. So what's this Jabber stuff? This is a very brief overview. It's a set of open technologies for real-time messaging, presence, multimedia, negotiation, and more. It's really just an XML router. It was invented by Jeremy Miller in 1998. It's powered by streaming XML, which is kind of a bizarre concept, but Tim Bray didn't like it, but it works very well for us. So we send streaming XML over long-lived TCP connections, essentially. You just open a TCP socket, and you incrementally parse XML, and you can do Jabber. That's the short version. So we have a client-server architecture which enables us to build a decentralized network for inter-domain messaging. It's basically like email, but really fast with built-in presence. But it's not one open source project. Jabber is different from something like Apache or Linux. Multiple code bases. There's open source code, there's commercial code, there's shareware, there's freeware, there's all sorts of different kinds of code that we have because we really focus on the protocol, not the code base. So our core protocol has been standardized through the IETF. It's not a final standard, but we're working through final standardization of that with the Internet Engineering Task Force. When we took it there, we didn't call it Jabber, we called it the Extensible Messaging and Presence Protocol, or XMPP, because you need a four-letter acronym for all good protocols. That's defined in RFCs 3920 and 3921. I wrote those, and I don't suggest that people write RFCs unless they have a death wish. It's been widely deployed. How many users do we have? Well, we really don't know because of the decentralized architecture. We don't keep track of who's downloading servers and how many people are using this stuff. We estimate there's about 50 million users. And that's for instant messaging. There's a lot of other stuff that you can do with Jabber. It's because it's not just IM. It's general XML routing, essentially. So there are lots of applications beyond IM. And we're continually defining extensions to the core protocol, but we don't do all those all in the IETF because we have limited bandwidth and it would take us too long. So we define those in something called the XMPP Standards Foundation, which until recently we called the Jabber Software Foundation, but we never did any software, so we decided to change the names and more accurately describe what we were doing. So that's great, right? You have 50 million users, big deal. But how secure is it? If we've got 50 million people sending unsecured messages, it's not really a good thing. We're actually maybe harming the internet more than we're helping it. And we want to be good internet citizens. So what is security? Well, there's a lot of definitions. So I thought, let's visualize what is a secure conversation in real life. Because these are the analogies that we can use to figure out what security is on the internet. Let's say you have a good friend over to visit your home. It's your house, right? You know each other, you trust each other. He's probably not wearing some recording device to figure out what, take this home and then post it on the internet when he gets home. It's only the two of you, right? There's no people listening in. Maybe you've got someone out the window, you can close the window, right? Strangers can't enter your home like they can on the internet and intervene in these kinds of things. Your home isn't bugged, you hope. Maybe you check your room for bugs before you start to have your conversation. The conversation's not recorded, you're not recording it, your friend's not recording it. What you say is private and confidential. Right? If you take a walk on a hike in the mountains or you have someone over to your house, this is the assumption that you have, is that your conversation is private and confidential. Contrast this with the internet. The internet is a dangerous place. Don't use the internet. There are lots of potential attacks, right? We have man in the middle, we have unauthenticated users, we have address spoofing, we've got weak identity, rogue servers, denial of service, directory harvesting, buffer overflows in various code bases, spam, spits, blogs. There's all these nasty things that can happen to you, and it goes on and on. There's viruses, there's worms, trojans, malware, phishing, and farming. We have to come up with new terms for this stuff all the time because the internet is such a nasty place. You put a machine on the internet and see how long it takes to get attacked, right? There's information leaks, there's people logging things and you don't want them to log them, and so on. So how do we fight these threats in the Jabber community? Well, I have to first apologize, but Jabber is not a perfect technology. It was not originally built for high security. It was originally built by hackers who say, hey, let's get something working, we don't like AIM, we don't like ICQ, let's build something that's a real technology that we can develop ourselves and not be beholden to these large corporations, typically American corporations. I'm American, by the way, so we don't require GPG, we don't require X509, we don't require ubiquitous encryption, it's not Silk, it's not Hushmail, it's a very open technology. Maybe that's why we have 50 million users. How many people are using Silk and Hushmail and these kinds of technologies? It's not 50 million, I don't think. But privacy and security have always been very important in our community, and even though we haven't necessarily done a great job of that, we are at least trying to improve. So what have we done to help? Well, let's look at the Jabber architecture. Hey, this looks familiar. Clients and servers, right? Oops. It's a client-server architecture similar to email. So a client connects on a TCP connection, TCP socket, it's 5222. Or we have HTTP over SSL and these kinds of things, but the typical is a TCP connection over 5222, which if you don't want to do Jabber communications, you can close off that port and off you go. The client must authenticate. We don't have any of this, authentication is optional like you have in SIP and stuff like that. Original technologies was plain text password, obviously not a very good idea, but I still do it with the Telnet client that I use. If I connect on the same subnet, I don't worry about it too much. Hash password, which is the other early technique that we had. Then when we took things to the Internet Engineering Task Force and said, hey, we've got this great technology called SASL, Simple Authentication and Security Layer. And it has all sorts of mechanisms. It's defined in RFC 4422. It used to be 2222. So there are many SASL mechanisms. You can do plain, which is okay if you've got a SSL encrypted connection. Digest MD5, some people like that, some people don't. There's varying philosophies on that. External, so if you're using X509 or IPsec or something like that, you can use SASL external. Kerberos, there's a lot of guys at MIT who have used Jabber. They're using Kerberos, some of the investment banks, these kind of people. SASL anonymous, so you can have anonymous users maybe if you have a support, a technical support kind of application, and so on. There's a lot more. So all of our users are authenticated, and the server asserts what the from address is. So you can't say, oh, I'm service at PayPal.com. It just doesn't work that way, because the server is going to say, no, you aren't. The server informs other people what your sender address is, so you can't just assert that you want to be a certain person on Jabber. So what do these Jabber IDs look like? Well, they're logical addresses. They look like email addresses. I always use the Shakespeare examples. Romeo at Montague.net, Juliet at Capulet.com, Bard at Shakespeare.lit, these kinds of things. But they're not limited to US ASCII characters. So unlike email, you can have Yirshi at Czechy.cz, and you can have Plato at Hellas.gr, and you can have Thai addresses and Japanese addresses, and these all work. You can have them in the domain names too. I didn't want to get you too confused. The possibilities are essentially infinite. And you see people with Jabber addresses like this. It's pretty cool. So we have full Unicode, but it's good and it's bad, because now you can have some nice phishing attacks. For instance, my address is St. Peter at Jabber.org. What's the, does Aunt Tilly really know that this one at the bottom uses Cherokee characters instead of ASCII characters? Probably not. So she said, oh, this looks like my friend St. Peter at Jabber.org, but it ain't. It's someone else. So the clients should use pet names and things like this to try to get around some of the possible phishing attacks. We haven't seen these happen, but we need to be prepared. So these all get stored in your buddy list. Buddy list is a trademark term from AOL, so I don't typically use it. We call it a roster in Jabber. So the server stores your roster so that when you connect to various clients, it's all there for you. You don't have to store it on your local machine. And the server broadcasts your presence or your availability. So once you get online, you can say, hey, everyone that I care about, here I am, I have network availability. And this is called presence. But the server only sends this to people who are authorized. There are some instant messaging, consumer instant messaging systems out there which will give your presence away to anyone, which is really not such a good idea. We don't do the things that way. The server also must not expose your IP address, unlike something like IRC, where you log into IRC room and everyone knows what your IP address is. It's really not such a nice thing, I think. Most of the traffic goes to the server. We can do some peer-to-peer stuff. We actually have a serverless mode that the one laptop per trial people are going to use. But most traffic, typically, in typical implementations and deployments, goes to the server. Traffic is pure XML. and the servers reject malformed XML. So this, and they can validate even against the schemas if they want to. Typically people don't do that, but at least they check for well-formed bits. This makes it difficult to inject binary objects, difficult to propagate malware. In part, what this helps us do is break the alliance between the virus writers and the spammers. There's actually sort of this unholy alliance between the virus writers and the spammers. And they get along quite well because they're all trying to harm us in various different ways. So we basically don't have what's called SPIM, which is spam over IM. And then the SPIT, which is spam over internet telephony. And we all know what blogs are, of course, spammer blogs. We basically don't have SPIM. I'm not going to say that we don't have any. I mean, I've been using Jabber since 1999, and I don't think I've ever received any spam except when I was connected to ICQ over the various gateways that we have. But I'm not going to say that we don't have it. So why is that? Well, it's hard to spoof the addresses. It's hard to send this inline binary stuff that, so you get image spam all the time now, so to get around the basic filters. We have an XHTML subset, which is kind of a safe subset of HTML that we can do formatted messages, but not send scripts and images and these kinds of things. The clients are very much encouraged to check with the user before accepting any file transfers. I'm not saying we're immune to spam, but we have a lot of spam fighting tools that we've been working on that we should have ready in time before the spammers really discover us. For instance, we can do a challenge response to figure out if something is a bot versus a person, or before you register an account. And we're working on ways to report spam to your server, and your servers can report to each other, and we can figure out if there are rogue servers on the internet. We may even work on replication systems farther down the line. And the spammers, one thing they need to do is overcome rate limiting. So we limit the amount of packets that you can send to the server. And this is the way most of the servers are written, to try to prevent rogue clients from connecting to legitimate servers. So if you really want to get serious about spamming the Jabber network, you either have to launch a rogue server, but you get discovered pretty quickly because we check all of the from addresses, or you have to launch a distributed attack. So get a lot of different bots connecting to various different servers and have enough of them that you can get under the rate limiting and send enough spam to really make it worth your while. It's not impossible, it's just harder than other networks. So if you've got email, you might as well attack the email infrastructure first, because the Jabber infrastructure is just too much of a pain. And we don't really have any rogue servers yet, but if we do, we're going to have to figure out ways to tell each other that they exist. So server federation, by which I mean interdomain communication, is optional. When I said we have 50 million users, those are not all users on the open internet. In fact, a lot of people use Jabber at universities or at companies, and they don't connect to the rest of the network, which is just fine. They're using our technology the way they want to use it, and we don't have any problem with that. So that server federation is optional, and there are many private XMPP servers out there. The public servers federate on a different port, so if they want to do federation, they open up a separate port from the client communication, which is 5269. DNS lookups, so we do DNS lookups to determine IP addresses. Obviously, DNS can be poisoned, so I'll talk about that as well. There's only one hop between servers, so unlike email, where there's sort of this best effort delivery, and I get it part of the way, now there's another server in between and another server. We only have one hop between the servers, which is that direct server-to-server connection. Server identities are validated. We have a couple ways to do that. The first way that we have the server dialback, which we instituted in 2000. So until October 2000, you could still spoof server domains on Jabber, and it was a bad thing, so we got rid of that, and we said you can't connect in the old way. This is ancient history for Jabber, by the way. I mean, we've been around since '99, so we do reverse DNS lookups. If you tell me that you're FOSDEM.org, I say that's very nice. Thank you very much for saying that you're FOSDEM.org. Let me check into DNS and see who FOSDEM.org really is. I check to that IP address. I say, hey, I have this connection over here who says he's FOSDEM.org. Is that really true? And there's some keys that get passed back and forth, and then we can check whether this server really is FOSDEM.org. And if I get back from the authoritative server, then I tell this connection, oh, that's, you're okay now. And if I don't get back the right key, I say, sorry, I'm going to close this connection. So this effectively prevents server spoofing. And the receiving server, once that connection is open, now checks the sending domain on every packet. And so if the server was FOSDEM.org, and now it wants to say that it's PayPal, Jabber.org, which is me over here, is going to say, no, I'm going to reject that packet and I'll close that connection because you're trying to do the wrong thing. So basically, we have none of these messages from people who are not who they say they are, because we validate all the identities on the network. Now, obviously, if you do DNS poisoning, you can invalidate this, because if you poison DNS, you can get the wrong results, right? So if we need something stronger, we use something called transport layer security, which is RFC 4346, which is the IETF upgrade to SSL. So this enables us to do channel encryption, and then if you use channel encryption with TLS and certificates, and you refer to the SASL external mechanism, you can really tell who someone is. Well, there's still maybe some problems, and some people just do a direct IP-to-IP connection for server to server if you really care about it. So this enables us to do strong authentication of other servers, but only if you're not using self-signed certificates, because if you're using self-signed, anyone can do a self-signed certificate, right? It's totally meaningless. The problem with this, as usual, gets back to money. These are dollars, maybe I should have used zeros here. So real X509 certificates are expensive. How many people here are going to go to VeriSign or Thought or something like that and buy a real certificate for their Jabber server? They're probably not, because we're just a bunch of hackers. We don't have this kind of money. So what we want is free digital certificates, right? Free is good. Free as in free beer for XMPP server admins. So what we've done is we've set up an intermediate certification authority for the Jabber network, and that's at xmpp.net. So our root CA is StartCom, which is a CA based in Israel, and then we set ourselves up as an intermediate certification authority through StartCom to offer free digital certificates to Jabber server admins. So if you have a Jabber server and you want a free certificate, you just come to us, and we have free cert. This really encourages people to do end-to-end channel encryption. So hopefully we'll work with other CAs in the future. I've done some work with CA Cert, and you can do the CA Cert route as well, because I work with those folks to get the XMPP support in there. So this basically makes channel encryption a no-brainer. And we should, by the end of the year, we're really trying to work out so that we have mostly ubiquitous channel encryption, both server-to-server and client-to-server. So this really causes problems for Mallory. I don't know if you remember your security characters. Mallory is the man in the middle, right? So if I have my client and the server, I want to connect to my server. Mallory is now foiled. But it doesn't really help us with Isaac and Justin. Isaac is your ISP, and Justin is the justice system. So your ISP could still be listening into this traffic, even though you have an encrypted connection between the client and the server. It's now unencrypted, it's clear text, while it's inside that server application. So your Isaac could be listening into everything that you're saying because he's your ISP. And maybe Isaac is friends with Justin, and Justin wants to know what's going on as well. Right? So it doesn't really help to have ubiquitous channel encryption if within the server applications we have clear text. So we need end-to-end encryption, or what we call E2E. And we've had various attempts at this because we're not security gurus, and even the security gurus have sometimes different advice about how we should be proceeding. So the first way we did this was OpenPGP. We have a series of documents called ZEPs, and this was ZEP 27. It's actually, we had this very early on in the Jabber community, to use OpenPGP to encrypt our packets that we send for full encryption, end-to-end. This is great for geeks, right? How many people here use OpenPGP, GPG, something like that, right? See, rock on, right? We're a bunch of geeks. We use this stuff. But Ann Tilly does not use PGP, and she never will, right? She's a very sweet lady, that Ann Tilly, but she's just not very technically savvy. So then we said, our second try, we took our stuff to the IETF, and the IETF said, oh, you don't want to use OpenPGP. You need to use SMIME. Now, SMIME is great technology, but there are more SMIME implementations out there than there are SMIME users. I mean, how many people are signing their email with SMIME? All right, there's 3 or 4 of us. Yeah, I do that, right? But it's great for geeks. And even the geeks here aren't using it, right? And it's great for some employees, because there are some companies that you get a smart card, or you have in the U.S. Army, they have these CAT cards, and you just slip it into a machine, and all your credentials are there, and they're using X509. But they have control over their user base, so they can tell people that you need to use this card, or else you can't get on the network. But again, Ann Tilly does not use X509, and She never will. She's probably more likely to use GPG. What about XML encryption and digital signatures? Well, it may seem like a natural thing, but there really has not been much developer interest in this. You've got to do canonicalization, which is C14N. It's really no fun. And it doesn't provide what we call perfect forward secrecy. So if your keys get compromised, someone can go back and read all your old messages, which we really don't think that's such a good thing. So then there's something called off-the-record communications. I don't know how many people use GAME or ADM, right? And you have off-the-record communications. It's really cool. It's a great idea. It's opportunistic encryption, something like SSH, right? So you get that key once, and then once you connect over SSH again, as long as the key's the same, you figure it's okay. Now, someone would have to attack that first connection and then attack the future connections. But once you've accepted that key from your server on SSH, you're pretty much happy, right? So that provides perfect forward secrecy, the OTR technology. But it encrypts only the message body. So if you say hi, it encrypts the hi, but it doesn't encrypt anything else that's in the packet. We need to encrypt the entire packet. Why is that? Well, because we're more than I am. We're not just sending a couple messages around. We're sending SOAP, and we're sending forms that might have sensitive data in them for workflow applications. We might want to protect the IP addresses that we send in a multimedia negotiation because we don't want to expose IP addresses. So we have been working for a while on a technology called encrypted sessions. It has a very large set of requirements, which sounds like it would be impossible to meet. But OTR pretty much meets them, and we've kind of tweaked how that works and followed some other technologies. I worked with a guy named Ian Patterson on this, and a guy named Dave Smith who sort of started the ball rolling. So the packets are confidential, right? We don't want anyone to be able to read things in transit, even Isaac and Justin. We need to know if the packets have been tampered with, so that's integrity. We need to know if the packet is replayed, so if someone sends us the same packet again and they're trying to foil our encryption technology. The compromise of the keys does not reveal the past communications. That's perfect for our secrecy. We don't want to depend on PKI because people don't use PKI. PKI is not widely deployed enough and never will be for everyone to be using this technology. So we don't want it to be necessary. If it's there, maybe we can reuse it. The entities are authenticated to each other. Just like when your friend comes by your house, you know that it's your friend. He's not faking it. He's got some mask on or some suit, it's the same person. Third parties can't identify who the identities are who are talking. This is a nice thing. We can repudiate messages if we want. And we have robustness against attack. You have to sort of go through a lot of different things in order to attack the technology. If we find bugs in that technology, we want to be able to upgrade it to new versions, so we need some good versioning. And we want to encrypt the full packets. And ideally, it would be implementable by your typical developer and usable by your typical user. So it sounds impossible. Is it just a dream? Well, maybe it is, but we're trying to figure it out. So how do we address all these requirements? Well, we're essentially trying to bootstrap from clear text to encryption, which is what Diffie-Hellman does, right? So we try to do an in-band Diffie-Hellman exchange. This technology, it's actually more of an approach called Sigma, which was published years ago, and that's what gets used in IKE, which is Internet Key Exchange that the IETF came up with. So what we've done is we've taken all those insights and we're trying to work a way to do that over Jabber because we have a real-time communication system. We don't have to do object encryption like we do in email because you never know if when someone's going to pick up the email. We can encrypt it essentially in real time and use the fact that we have sessions to have a smarter encryption technology. So we have a bunch of ZEPs that talk about this, so 116 and 188, 200. And it's really become a major priority for us in 2007. And NLNet has decided to give us some support to do some work on this, and we're very appreciative of their support. And we'll be announcing that, we're announcing that right now. So we're pursuing a full security analysis to get these technologies reviewed by real security mafia people. They call themselves the security mafia. I don't know, it's always kind of scary, but real security experts to do a security analysis and code bounties for projects out there, libraries and client developers, to try to get this code out there so that we can have a couple libraries maybe that people can just drop into their clients, and then we can have end-to-end encryption. And we're going to be posting more about this at our blog. We don't do press releases anymore, we just blog. So we have a blog at blog.xmp.org, and we're really shooting for widespread implementations at the end of the year. So how are we doing on all these threats? I went through 20 threats out there. Well, we're pretty much spam-free. At least I'm spam-free, and I have 1,500 people in my buddy list, and I've never received any spam. So I figure I would be a good spam hole, you know. I mean, if people are going to get it, it would be me. One of these days, someone's going to launch a denial of service attack just against me, I think. It's hard to spoof the addresses. We have this pure XML, so it really discourages malware. The DOS attacks, they're possible, but it's not easy, and we're trying to make it as hard as we can. We have very widespread channel encryption in all the server implementations. We're giving away certificates to try to get people to use this stuff. And we're working hard on end-to-end encryption. And Jabber has been very widely deployed in a lot of high security environments. They don't like to talk about it because they don't like to talk about anything. But basically all the Wall Street investment banks are using it. A lot of them use Kerberos, or they have X509 because they've got little smart cards that you have to use to get onto the system. A lot of U.S. military applications that I don't know about, and even if I did, I couldn't tell you. MIT, and MIT's famous as, that's the place where you hack into networks and stuff like that. They're using Kerberos as well, I believe, for their authentication on their Jabber server. We've had a lot of public servers on the internet. We probably have, I would say 15,000 or more servers on our network, and it's been out there since '99, obviously it's been growing. We've never had any major security breaches, as far as I know, through Jabber ports. There's no people installing Trojans on via the Jabber ports. They might do it over HTTP with PHP hacks and things like this. But it doesn't mean that we can be complacent. There's always more to do. We know that security is a never-ending process. We are encouraging people to analyze our technologies and try to hack into our network if they can, right? Because that's how we learn. And if things break, we'll fix them. And if they don't break, we kind of figure that, hey, maybe this is a good thing. But we need to keep improving our technologies. We have a security mailing list. I actually just reset this up this morning because we want to be able to have ways for people to just talk about security stuff. So we have security.xmp.org. And I say, join the conversation, and let's try to build a more security. So thank you, and I hope you have lots of questions for me. Come on, it's security. It's a controversial issue. You have to question some of my assertions. I said things, but they may not be true. How can you believe me? Okay, would there be a way to have encrypted server-side logs? Yes, there is, in fact. So we have, I didn't talk about it here because I forgot about it. So we have a technology for what we call message archiving. So let's say you've got a web client, right? The web client isn't going to keep, a lot of people like to keep their IM logs. So you can go back and search through them and find out, yeah, last week I was talking to Dries and he mentioned something, and let me go back and find it. I don't personally log my IM because it's not encrypted, so I don't like to keep it there. I do encrypt my file system, but how much do I really trust it? So we do have a method for doing that we've defined for archiving messages on the server side, and then you use some key materials that you come up with to securely save those logs on the server, so that even though you've logged the conversation, only you can get at that information. It's not implemented really yet. We have a couple people working on implementing it. There's some things that the clients need to do and some things that the servers need to do to make that happen. But we have to find a way to do that. It's a question of getting it implemented and deployed. This guy's a question here. Yes? Well, what do we do against rogue servers? Well, again, we haven't had any, so we haven't really worked out some of the techniques. I mean, so let's say if we had rogue servers. So yeah, if we had rogue servers, so let's say we had spimmer.com, spimmer.biz decided to attack our network. Some of the servers have dynamic whitelisting and blacklisting, some of the server implementations. So you can dynamically say, I don't want to communicate with certain domains. I don't know that all the servers implementations have that. Obviously, you can block it before you get to the application layer, and you can block it with IP tables or something like that, right? I mean, if we had rogue servers, if we had a lot of rogue servers, we'd really care about this. If we had one rogue server, people would learn about it pretty quickly and try to block it. Yes. So, yeah, so you could write your own HTTP server, which kind of looked like it did all the right stuff for the protocol, right? And then it did nasty things after that. Or it just sent a lot of packets. We also have rate limiting on a lot of the server implementations have rate limiting for server communications as well. So if we started to be flooded by a certain server, they would get rate limited, and then they could send fewer packets, and so they would have to stay within some boundaries, typically, of how much traffic they could really generate. We haven't seen those yet, but I'm sure we will. I mean, once we have enough, part of the problem with instant messaging, which is the main application for Jabber, is that we have these communication silos, right? There's MSN and Yahoo and AOL and ICQ, and so we don't have an open network like we do with email, which is a bad thing because you can't talk to everyone and you need 4 IM clients. But on the other hand, it could even be seen as something of a good thing because we don't have the kind of open communications that we have with email, so it's not as much of a tempting target to try to attack. I personally would prefer open communications over these communication silos. But once we get rid of the silos, and this is the excuse that AOL always uses, oh, we want to open up, we really do, but we need to protect our users. Well, maybe you do and maybe you don't. If you would use a real technology like XMPP, you wouldn't have to worry about it. So I think that's one of the reasons that we don't have a lot of spam in IM. Now, they do have spam on things like ICQ because there's consecutive numbers, right? And so you can just, hey, I'm going to spam this number, and I'm going to increment by 1, and I'm going to spam the next number, and I'm going to spam the next number. It makes it very easy. And I don't know how AOL does it for AOL as the messenger, or MSN does it, but there's probably some directory harvesting attacks that you can do and find out all the addresses, and then start spamming them. It's a little harder to do that in Jabber. The only directory harvest attack I've heard of in Jabber was on a server where the email address was the same as the Jabber ID. And so they attacked we have these user directories. They attacked the Jabber user directory just to get the email addresses, and then they would then spam by email because it was too much of a pain to send spam by Jabber. But at least they could get those addresses because they knew they were the same. This was actually, there are a lot of big Jabber servers in Cuba for some reason. And this was one of the servers in Cuba. Yes?
How do people tell the difference between Java and email?
Oh, I'm sorry. I was pointing to this person way in the back, but I'll take your question first. How do people tell the difference between a Jabber address and an email address?
Yeah, same. Really same.
Well, we should be using URIs, right? I mean, if I put a domain name on the side of the bus, right, and it says FOSDEM.org, what the hell is that? Do I do HTTP? Do I do FTP? Do I do, I need a protocol in front of something. So yeah, there's confusion about sometimes between Jabber addresses and email addresses because you should put on your business card, Jabber ID is this and email ID is that. Now, I happen to be one of the admins for the Jabber.org server. And I'm also one of the mail postmaster and all that kind of stuff. So what I will see is that people are trying to send spam to addresses at Jabber.org that are actually Jabber IDs, because there's only like 5 people that have email addresses at Jabber.org. Everyone else just has Jabber IDs. So I see all these people who advertise that they have Jabber ID at Jabber.org on their website or something like that, and the spammers are now going through and trying to harvest these and send spam either to or from these addresses that don't exist. So it's really kind of sad for the spammers, in fact, I think, that the Jabber IDs are different from the email IDs. But the only categorical way to tell is to put the URI scheme in front of it, and then you know what the entity really is. And we have a URI scheme, it's RFC 4622. So we have an XMPP URI scheme. So if you put XMPP colon St. Peter at jabber.org, you can tell that is different from mail to at jabber.org. And that's what URI schemes do for us. Yes? If you just speak, I'll repeat your question. So the question is, we've set up this certification authority, and someone now comes and says, oh, I'm PayPal, please give me a cert. Well, sure because we do a lot of stuff to figure out whether you really are who you say you are. And so we have actually a couple-step process. One is that you request an account at xmpp.net, which doesn't get you to the certification authority at all. All that we do is we do some Kunis lookups and we verify that this person is associated with the domain. This is a good question. And so what happens is that a lot of people will say, oh yeah, I want to register an account at xmpp.net because I want to get a certificate for this certain server. And then we do a Kunis lookup and we see that they're not associated with this domain at all. And so then we say, are you really associated with this domain? Do you mind if we can contact the domain owners, the registrants for this domain? And then they say, oh yeah, please don't. Yeah, that's okay. I don't really need this account. Or they say, yeah, I really am the Jabber server admin, but I don't have access to all the postmaster addresses and all that kind of thing. So then we contact the real owners and say, hey, is this person who asserts that they're associated with your domain really part of that domain? And if they say yes, then we will let them have an account at xmpp.net. But that just is the first step. So in order to get to our certification authority, you have to get from a certain URL, when we do an HTTP post and all these kinds of things, to go from there to then get to the internet, to the certification authority website. And then there's all sorts of other hoops you have to jump through once you get to the certification authority website to prove that you really are associated with the domain, and they do all sorts of checks of the IP addresses and the mail servers, and they send it to one of the canonical addresses from RFC 4122. And so on and so forth, and then you get this key, and you got to come back within a certain amount of time, and then you can really get your certificate. And then if we find out that you really aren't who you say you are, we'll just revoke your certificate and throw you out. So we do a lot of things to try to prevent people from trying to game the system. But I'm not going to claim that it's perfect, because if you claim perfection with regard to security technology, someone will figure out a way around it. But we're trying to do the right things. That's the long story. Yes?
Can you use a Jabber technology like Tor or communications, like using Jabber Tor on your routing?
Oh, yeah.
It's still very old to practicalize it. People can go and ask questions to server, and the server can server.
So you're talking about onion routing?
Yeah.
Okay, so there's a technology called Tor. How many people have heard of Tor or onion routing? Oh, cool. I use Tor. Tor is cool. So Tor is really cool, and you can do Jabber over Tor. I haven't set it up because I had trouble setting up the service, the Tor services. I didn't spend enough time to figure out how to set up Tor services. But you can set up Jabber as a service under Tor, and then you can use the Tor onion routing to hide what the path is to the network and those kinds of things. One of the problems is that if you've used Tor, you know that there's some latency involved. And people don't like latency when it comes to instant messaging. They're just not very tolerant of it. So even though we can do it, I think very few people will, because they're typing really fast and they want to get communications right away. So it can be done, but I don't think that a lot of people will ever use it.
I see people
Really? That's the thing. If you have a low latency application, right, like VoIP or something like that, then they get very frustrated if things aren't going through right away. But yes, it can be done. I haven't tested it myself. I should do that though. That's a good idea. Because I like the concept of Tor, especially if you're in a country and you're trying to be a journalist or doctors against borders, or these kinds of people who are trying to work in Myanmar or someplace like that, you want to be able, you don't want people to know what the path is of your communication. So how do we ensure that TLS will be used if it's available? So we are able to, as a server policy, you can say that TLS is required. So a server can not only offer TLS, but require TLS. We're not probably going to do that very soon because we're still waiting for more people to get certificates. But I can see the day in maybe 12 months or 18 months where a lot of servers will just say, I'm not going to accept unencrypted connections. So I require TLS. You must have a certificate. And that day will come, but we're working towards that. But all the servers and the underlying protocol have a way to require the use of transport layer security. We don't have a way right now to do kind of a trace route, right? So if I'm a client over here and you're at FOSDEM over there, we don't have a way right now to check the whole path and know that there's TLS. But of course you have to trust all the entities in the middle so you're back to square one at that point. Because you'd have to trust that your FOSDEM.org is really giving the appropriate results for whether it's using TLS for the connection between you and the server and the certain connection. So, there's kind of problems there. And if you're using some HTTP connector that's kind of a proxy in there, to really check that full path, there's a lot involved. At that point, you might as well just use end-to-end encryption, I think. Yes? No, there's no support required from the server. I mean, we don't trust the servers. I mean, people who want to do end-to-end encryption don't trust the servers. And they're justified in not trusting the servers. Because Isaac and Justin might be there in the middle, and they might be trying to listen in. So there's no server support required at all. There is, if you want to do certain forms of end-to-end encryption, we probably want to have a way of storing your keys on the server, your public keys, not your private keys, but to store your public keys on the server. So you might have to have some level of trust, I suppose, in your own server, in the sense that it's not, but if it's going to compromise your keys there, you don't have to store them there, or, that would be helpful for certain kinds of scenarios for offline messaging, because, you can send a Jabber, you can send a message, and it gets stored on the server, and then it gets delivered when the other person comes online. But obviously, you're not going to do that with this end-to-end encryption technology, because at least not right out of the box, because that person's not going to be able to read the message. So we have some fancy stuff that we do to have an offline mode for this as well. Yes? So do I foresee problems of people, governments, let's say, or organizations saying, we're not going to allow any traffic that is trying to use this end-to-end encryption technology? Well, I would foresee corporations, a lot of corporations, they have legal requirements, at least in the States, for Sarbanes-Oxley and these kinds of reporting requirements and SEC. So they need to actually store the messages that people in their corporation send for legal purposes. And they won't be able to use this technology, obviously. But that's going to be a corporate policy. I don't know at the government level, I don't know how they're going to enforce that. I'm not sure. They could try to do traffic analysis, and if you send things in certain namespaces in XML, they would throw it out, those kinds of things. But is that possibly going to happen? It may, because we know who's involved and who cares about these things. But we may care more about end-to-end encryption than they care, or even pay attention to Jabber. But the day may come when I certainly see that for corporations.